Hi students, I am going to start volume 2. Already we completed for the last class 6.9 and 6th chapter are totally completed. Okay, so now and first volume are completed. Now we are going to start the second volume 2, chapter 7. Seventh chapter, applications of differential calculus. Applications of differential calculus. The introduction topic, derivative as slope. Derivative as slope. Then subtopic, slope or gradient of a line. Slope or gradient of a line. The statement, the ratio of the vertical length to the horizontal length is always a constant. The ratio of the vertical length to the horizontal length is always constant. See the diagram, x-axis and y-axis. So draw the non-vertical line and vertical line change in x and horizontal line change in y. Okay, so now change in x and change in y is a horizontal line. So now this ratios is called the slope of the line L and is denoted as M. Okay, so now the non-vertical line is L. Now the ratios is called the slope. Okay, slope of the line L and it is denoted as M. Okay, so now next topic, slope or gradient of a curve. Slope or gradient of a curve. Let y equal to f of x be a given curve. The slope of the line joining the two distinct points x comma f of x and point of x plus h comma f of x plus h is f of x plus h minus f of x divided by h is a Newton quotient point. The Newton quotient point, f of x plus h minus f of x divided by h. The first point of x comma f of x means y is equal to f of x, and x plus h comma f of x plus h. H means is change in point. Change in point. Say the, for example, 2 comma 4 is x comma f of x and another point of 4 comma 6. Okay, so now in this fourth point, 4 point is 2 plus 2, so x plus f of x plus h. The h means is a change point of 2. Okay, so now the change in point of 2, so 2 plus 2 means 4. Okay, so now the, for example, taking the limit as h tends to 0, we get limit h tends to 0 f of x plus h minus f of x divided by h equal to f dash of x. Okay, so limit of Newton quotient, which is the slope of the curve at the point x comma y or x comma f of x. Next topic, derivative as rate of change. Derivative as rate of change. The velocity and the acceleration at the time t is denoted as velocity of t equal to ds divided by dt. ds divided by dt. And acceleration of t equal to dv divided by dt. dv divided by dt. Velocity, as usual, the differentiate with respect to t, so dv divided by dt equal to d square s divided by dt square. d square s divided by dt square. Okay, so all are equal in acceleration value. Now the remarks, first one, speed is the absolute value of velocity regardless of direction, and hence speed equal to determinant of velocity of t equal to the determinant of ds divided by dt. Okay, so now the second point, the first one, when the particle is at rest then velocity of t equal to 0. The second subdivision, when the particle is moving forward then velocity of d greater than or equal to 0. And third subdivision, when the particle is moving backward then velocity of t less than 0. And fourth point, when the particle changes direction velocity of t, then the changes its sign. Okay, the sign changes. Now the third point, if tc is the time point between the time points t1 and t2. So now tc is the time point between the time points t1 and t2. So now t1 less than tc less than t2, where the particle changes direction, then the total distance traveled from the t1 to time t2 is the calculated as determinant of s of t1 minus s of tc. S of t1 is a minus s of tc plus determinant of s of tc minus s of t2. Okay, that's all. We will meet the next class.